Welcome to today's webinar. We'll go ahead and get started. I see people are still coming in, and so that's great. I'm really excited about this new webinar topic. This is actually the first time that we're giving this webinar topic. We've had so many webinars before, and we've even had joint webinars directly with the CEO of Octopus Deploy, Paul Stovall. And I'm excited about the tremendous response we've got. We have a load of people who have signed up for this webinar. I see people are still coming in, getting settled, and there's a few logistics to talk about. There is a Q&A window, and you can write in and ask questions along the way. I'm pretty good at answering the questions during the webinar and working those in, but I will make the commitment to you that we won't close the webinar until I've answered every question. I've got more time at the end. My goal is to get you in and out in 30 minutes and get the information transferred. And I know each one of you has a busy day. We have a good variety of people that are in this webinar, all the way from individual developers to CIOs, plenty of architects, a few CTOs, software development leads, a few development managers. And so all of you are in leadership positions, and we're all going to talk about how to structure and design the DevOps architecture of a DevOps environment that's powered by Octopus Deploy, and talk about the specific things that you need to think about when you're using Octopus Deploy specifically, and also things to think about to enable your team that are going to directly impact your success with the product. So let's jump in and kind of do our overview here. You just by definition of you being here at this webinar, you're not hearing about Octopus Deploy for the first time. And Octopus Deploy, it's the first, and it's the most mature product for automated deployments, and it makes it easy to orchestrate releases and deploy .NET applications either on-premise or in the cloud. And whether you've already got Octopus Deploy implemented now, or if you're planning on doing it, you need to really think about the architecture. You need that streamlined DevOps architecture to promote your software across pre-production and production environments, and even some steps before you do your first deploy that'll help with success. And you also need to limit who can deploy to production, ensure releases have been tested first, and then block the promotion of broken releases. So there's just some common questions that we get about how to structure deployable application components and how the deployment fits in with other elements in the DevOps pipeline. And so we'll cover that. We'll cover the architecture of a complete DevOps pipeline that integrates Octopus Deploy with Azure pipelines. We'll talk about how to structure the code in your Git version control system, because that can have a profound impact on how easy it is. And there's some rules of thumb that when followed can make the structure of the automated DevOps pipeline environment fall into place nicely. So as we get going, if I could have the assistance of a few of you in the chat window, just confirm that my audio is coming through loud and clear, and I'd appreciate that as we get going. All right. Okay, so let's talk about our agenda and how we're going to progress through here. We're going to really dive into the objective, and then we're going to talk about what does architecture mean in the DevOps world, and then we're going to go through the 7 parts, the 7 keys to DevOps architecture for an Octopus Deploy pipeline, and we'll dive into each one individually. We'll talk about how to integrate Octopus Deploy and the build server, and how there's some really important things to think about in order to get that working right. And then we'll talk about some next steps. So let's get going. All right. All right. So there is a free offer, and this session will probably be giving away a lot. But I want to give away a free ebook version of my latest book. And so just send me an email, and be happy to get that out for you. Actually, here on the webinar, Rain is my logistics assistant on the webinar today. So if you even post in the Q&A window in the Zoom software asking for the free book, she can actually get you taken care of right here during the webinar. If you want a print copy, you can go to lulu.com and search for .NET DevOps, and you can get it there. All right. Now, another resource that you might be interested in is a past webinar that we've done with Octopus Deploy, and that was specifically talking about database DevOps with Octopus Deploy, and what makes the database different, state-based versus migration scripts, rollbacks, etc. And we made a bit.ly link for that YouTube video. It's bit.ly/Octopus Database. And so if you just go there, and you can stream it directly from YouTube, and you can watch that webinar, because software systems are complex, but anything that owns state has specific things that we need to think about, and a SQL Server database is definitely the most common state owning component that must be deployed. And so that was a really fun webinar, and that can be a resource for you. Also, if you do not subscribe to the Azure DevOps podcast, then I'd encourage you to check it out at www.azuredevops.show and give it a listen. Actually, we've had Paul Stovall as a guest on the podcast talking about Octopus Deploy, and we talk about success stories in DevOps all up and down the chain. All right, so let's get into the objective. Now, there's 3 things that we need to think about. And for the context, you are the leader, all right? And I know some of you have management titles in the webinar, just kind of taking a glance, and lead developer, but I'm just going to kind of consolidate it. Every one of you is an architect, all right? You are the leader of a software organization. So with the right strategy, things are going to fall into place. With the wrong strategy, no level of execution can make it great. When I say strategy, architecture is a special type of strategy. And there's 3 types. There's three elements in this technical strategy, which is architecture. First is the design of the system, the software architecture. The next is the design of the organization that builds the system, because they all need to work together and get it done. And the third is meeting budget and schedule targets. Now, we all know if there's a family of 5 or a family of 6, and you say, you know what, we need a house. There is a huge spectrum of houses and housing types and construction types that can house and meet the needs and provide shelter and bedding for a family of a certain size. And so the same thing with software. There can be budget ranges and schedule constraints. And so that's really important, because there's no one size fits all, just like there's no one size fits all house. So DevOps also gives us a model that can help ensure that we meet and identify all of the needed architectural elements. So there's 3 ways of DevOps. The first way is flow. The second way is feedback. And the third way is learning. And we'll incorporate that as we go through. And as an architect, you need to think about flow, feedback, and learning, and make sure that in the design of your DevOps environment, you have all of those elements, okay? Okay, so a DevOps environment is a system. And it can be easy to think of architecture as the structure of an application, and it is. You definitely need to design the structure of an application properly. But the DevOps environment itself is a system. And you need to design this system, not just the .NET application. All right. The inputs of the system are a feature request, a change request, usage data of it running in production, where you learn, oh, something's not going well, I need to change it. And the output is a new feature that the users can use, or a change that they can use, or better telemetry. I'm going to actually shrink myself a little bit. Better telemetry. And so that is the DevOps environment from a system perspective. And we are right here, or we're talking about designing that particular system. Okay, so we have a model at ClearMeasure for DevOps-centered software engineering overall. And in the center of our model is the automated DevOps pipeline. And then there's 5 layers of other characteristics that need to be a part of a DevOps environment to have a high-performing team, to be able to spin around that cycle of plan, code, integrate, package, release, operate, and learn, and spin that cycle faster and faster. And each of these layers has to have a sound strategy, be executed with discipline, and have objective measures so that you know if your strategy is working. And if we dive into the automated DevOps pipeline, which is where we're spending our time today, then we are going to see that there's a flow that we have to go through. Now, this is a highly shrunken technical blueprint for the structure and flow of a pipeline that pairs Azure pipelines with Octopus Deploy and has a continuous integration build, 3-tier deployment pipeline. I want each of you to have this. So Rain is going to post the download link in the chat window. And by the way, this is just the top third of the architecture poster. You can print it out at your local print shop. And this is the overall architecture for that automated DevOps pipeline. And it shows where the key 7 steps fit in. We'll go through each of those 7 key steps. And I'm going to talk about how each one of them must be done right in order to have success with an Octopus Deploy implementation. And so we'd like you to have that poster and the whole thing. I know you can't read any of it, but the whole thing looks kind of like this. And so you can download and get the high resolution PDF for the Octopus Deploy DevOps poster. Okay. All right. Okay, so let's get into, it looks like we will have to fix the link and get back to you. As reported that the link that was posted didn't quite work. So we'll get that fixed up for you. The 7 key elements of a DevOps environment are right here on the screen. There's stuff that you do before coding in order to design it well. There is the structure of your version control system. There's the build, there's full system testing, user experience testing, production release, and then telemetry observation. Again, it doesn't end when you launch to production, and it doesn't begin at coding. There's things on either end. All right, let's dive in. Let's look at our overview process, and then we'll dive into each of the 7 key elements. So here's the overall 12-step process from end to end when you think about Scrum or just even a Kanban board. And we have elements that happen before a developer does anything. And then, of course, we do a build, and then we do some testing, some deployments across environments, and then we have operating and supporting and have our telemetry. Now, let's dive into the first key element here, which is pre-code design process. These are the things that you have to do and think about before anybody writes code. These are the 4 types of design decisions that have to be in place in order for the coding to even come out right and have anything you need to deploy. I just wanted to touch on this briefly because if you get this wrong, it doesn't matter what you do in Octopus Deploy, it's not going to come out right. Conceptual definition, you need to figure out what the heck it is. User experience design is deciding how a user is going to use it. Technical design is discovering architectural elements of that feature that need to be added, or libraries or packages or design patterns. And then test design is, given everything else, what are the test scenarios to go through in order to make sure that it meets the needs. Armed with that, the developers can do a great job. Now, let's touch on version control system structure. There are some rules that you have to follow, or Octopus Deploy is going to be of no help to you. If you have a deployable package, for instance, that includes multiple pieces of software that need to be deployed, you can technically make anything work through hand-rolled scripts, but your life is not going to be fun. And so this is the version control structure that kind of cascades and flows through and makes implementing Octopus Deploy easy. And we don't normally think of, wait a minute, can't I just use Octopus Deploy on any application that's built in any way and is organized in any source control structure? Well, you can. It just depends on, is life easy or is it hard? Following these relationships here on the screen is going to make your life easier, regardless of what build server you're using, to pair with Octopus Deploy. And so a software system inherently has many applications. And especially with microservices, if you have an older monolith where the software system literally is one thing, then it's possible for there to be one application for the whole system. But more and more, software systems are comprised of multiple applications. And I'll just define an application as some things, some artifacts of code that are deployed at the same time and have the same version number. They have the same cadence of deployment and have the same version number. And so an application could have a web application and an offline job of some sort and a SQL Server database, and you could consider it the same application with the same version number, and you deploy all three of those pieces together. That's an application. But if you have one of those, an application, and then you have a different application that maybe looks for stuff and sends out email notifications, and you deploy it on a different cadence, well, now that software system has two applications. Each of those applications needs to be in a separate Git repository because they live on a different schedule. They live on a different deployment cadence. If you were to accidentally or inappropriately put those two applications in the same Git repository, then all of the downstream elements in your DevOps environment are going to be more difficult, and you're going to have a lot more custom scripting than is just necessary. So if you put each versioned deployable application, put the code for that in its own dedicated Git repository, then all of the things downstream are going to work a lot better for you. And so I wanted to touch on that because across customer after customer, it has had a profound impact on the Octopus Deploy implementation that we've done for them and assisted with them, and the success that they've been able to get even without calling us. And so follow these rules and your life is going to be easier. Okay, not saying that it technically can't work, but if you follow this model for the organization of your version control system, then everything downstream, including all of your Octopus Deploy implementations, it's going to go as it should. It's going to go as the product is designed, and your life is going to be easier. Okay, let's talk about build. All right, Octopus Deploy kind of has some assumptions when you package deployable components, and the best place to package deployable components are at the end of a continuous integration build. And so what we have on the screen is just the basic structure for the things that you need to have in your build process. And if you've ever used test-driven development, you've heard of the arrange, act, assert pattern. Well, guess what? Your build is kind of one giant test. So arrange, act, assert is kind of the mindset we can use where compiling the code into something that can run in a downstream environment is act, and then arranging it is getting set up. So we need to migrate our database. We need to get ready to run the test. We need to do some static code analysis and publish the test results, package them up, and then publish them. Now, before I talk about publishing formats, which can have a big impact on your Octopus Deploy success, I want to talk about runtimes just a little bit. There's a whole spectrum. You all know it. Probably all of you have software that still runs in an on-premise data center, or at least a leased data center where you have access to the physical servers. And you can have hosted VMs with Rackspace or any kind of hosting company. You can have VMs in Azure. You can, if you've adopted .NET Core, you might be running things in Azure Container Service or Azure App Services where you don't even have to worry about any operating system elements. There's a whole spectrum. And so when you package things, you need to have made these decisions. If something was packaged when it was supposed to be running on a VM, and now you want to run it in a container, there's some things that adjust. As much as we would say, hey, the source code should have no notion of where it's running, there are some things that you just can't avoid. And this is one of them. Now, you shouldn't have any kind of credentials or environment-specific things in your source code, but the nature of the runtime layer of architecture you need to think about. Now, let's get on to packaging. Let's take an example application, super common architecture. You have ASP.NET UI, you have an offline job of some sort, you have a SQL Server database, and then I'm also including acceptance tests because I'm going to tell you every one of us, every application needs full system acceptance tests. Because if you don't have any test automation for after a application has been deployed for the first time, there's a whole host of errors that you're just leaving for your users or manual testers to find. So we need to determine how we're going to package these things up. So we need to decide what the destination runtime is going to be to determine how many things need to be packaged. All right, so if we do a mapping and we're going to run in Azure PaaS, then we have one NuGet package, there's more and more agnosticism when it comes to the package format, even as simple as zip files. A zip file could be a package, but NuGet is still my favorite form for a package, and using octo.exe to package things up. This isn't going to be a how-to webinar, but you want to use octo.exe straight from PowerShell to package these things up for .NET Core. Integration with the project system in Visual Studio works great with .NET Framework, but if you're going to .NET Core, you're going to run that thing command line, okay? So if we are going to push those packages, we need one package for each deployable component. So yes, one package for the SQL Server database schema and the tool that's going to do our migrations. We have one package for the offline job, and we're going to have one package for the UI. And then we're going to have one package for our test library. If we're using InUnit or XUnit, yeah, it's just going to be a DLL with the supporting artifacts, but we're going to package it up. So we're going to have 4 NuGet packages. And then we have a choice. Where are we going to push it? Are we going to push it to the NuGet server in Octopus Deploy, or are we going to push it into Azure Artifacts? Now, for the tests that are going to run, you must deploy them. You must push them to Azure Artifacts, because the NuGet service inside Octopus Deploy is receive only. In other words, you push packages to it, and only Octopus Deploy can access that feed. Right? You will not be able to get that package back from Azure Pipelines in order to run the tests. So anything that needs to be pulled back in Azure Pipelines, it's going to have to go into the NuGet feed in Azure Artifacts, because the NuGet feed inside, it's not a NuGet feed as a full sense of the word. You can't connect to it with NuGet clients, only Octopus Deploy. So that's something to think about as you're determining. But the number of packages, oh yeah, you really need to look at how many deployable components you have, one package for each. All right, now let's look at the intersection between pipelines and Octopus Deploy. This is part of that poster that you have in high resolution format. So I know it's a little bit hard to read, but you will have no fewer than 3 environments, okay? No fewer, because there are 3 environment types. There's an automated testing environment with no humans allowed. We call that the TDD environment, where you run your tests. Then we have the manual test environment, and then we have the production environment. Those 3 types. You can have as many of each type as you want. So for multi-tenant, multi-instance software where you have a different production environment per customer, yeah, you're going to have many instances of production environment, but it's one type. Just like you can have many instances of a manual test environment. Let's count the names: staging, UAT, test, QA, dev, all of those that are dedicated for manual testing. That is the manual type, okay? And then you have the TDD environment type, test-driven development. And that is no humans allowed. It is only for test automation. So functional tests with Selenium, security penetration tests, Section 508 accessibility screen reader tests, performance tests, those would all be instances of test types and types of the automated testing environment, but you need no fewer than 1 of each type. So no DevOps pipeline for any application will have fewer than 3 environments, okay? That's a rule. If you break the rule, your life will be a little bit harder than it needs to be. And what we do is we pair Azure Pipelines on top of Octopus Deploy so that we get single orchestration. You can also do that with TeamCity. And if you go on the JetBrains site, you can see a webinar that I did with JetBrains on how to use TeamCity and Octopus Deploy together, and it kind of uses the same process. But let me just touch on that briefly. In Azure Pipelines, this is kind of your view, the stages across environments, and you notice how there's only a few tasks in each one. Well, that's because we're using Azure Pipelines to be the overall orchestrator, and then Octopus Deploy does the heavy lifting. Now, there's 2 integration strategies that you can choose between pipeline, your build server, and Octopus Deploy. The first is fire and forget, and the second is orchestrated. Fire and forget would be, hey, create the release, integrate with Octopus Deploy, and then done. And then you would promote by clicking a button in the Octopus Deploy dashboard, and that's fire and forget over to Octopus Deploy, and then everything else is in Octopus Deploy. So if you have an approver routine, approver button, that approve button would be in Octopus Deploy. Now, some of the differences why orchestrated can have some advantages, where you kind of layer over all the environments in Azure pipelines as a thin veneer, as a shell, and then quickly delegate to Octopus Deploy for all the heavy lifting, is with orchestrated, all of the logs for Octopus Deploy stream back into Azure pipelines so that you can see everything in one place. Second, approvers to approve production deployment, they can have a stakeholder account and don't have to have Octopus Deploy access, so that you can keep the people who actually have access to get into Octopus Deploy, keep that list as small as possible. Octopus Deploy doesn't have as much of different stakeholder and user types as Azure Pipelines is designed with, and so you can keep the approver button in Azure Pipelines. Also, Octopus Deploy is not a build server, and so tests need to be run on some build server. So tests can be run in Azure Pipelines after Octopus Deploy finishes a deployment. So we have Octopus Deploy do the deployment, then control returns back to Azure Pipelines, and we run the test. Now, caveat, some advanced Octopus Deploy scenarios, because Octopus Deploy was first, they are the most sophisticated, supporting any type of deployment scenario you can have. Some advanced Octopus Deploy scenarios have no parallel in Azure Pipelines. For example, tenants and channels really don't have a representation in pipelines, and normal day-to-day cases work fine. But if you're dynamically provisioning and configuring environments and creating parallel environments on the fly, then you'll have some deployments that happen in Octopus Deploy without tracking in pipelines, just because there's not really a correlation. But the happy path of most applications, in other words, 1, 2, 3 environments, works great. So the integration between pipelines and Octopus Deploy, I'm just showing you a few key things here. You want to pass in the release number, which comes in as release name in this particular example. So we're always telling Octopus Deploy exactly which release to deploy. And then also the additional octo.exe arguments. This enables variables to be defined in Azure Pipelines and then be passed to Octopus Deploy so that you can determine which system should own a particular variable, okay? And so we can say I'm passing in my variable and setting it to the value of Jeffrey. You can also pass in a database name, a connection string, as a few examples, all right? Now, once you get down the road and want to deploy to UAT in production, there's two choices. You can either use a deploy task or a promote task. And we prefer the deploy task because it gives you control of deploying whatever version. Promote is going to have logic. Well, let's back up a little bit. Strategically, decide which system is going to own the responsibility for deciding what version to deploy to an environment. Promote uses the logic baked into the lifecycle configuration. It'll deploy the version that's currently in the previous environment in your Octopus Deploy lifecycle. If you use the deploy task, that allows you to specify if Azure Pipelines is the pipeline orchestrator, then Azure Pipelines needs to be able to determine the version. Okay, so that's the difference there. Now, I mentioned the custom variables. In Octopus Deploy, and this is an Octopus Deploy screen, there's a magic checkbox. If you try to pass in, and probably many of you have done it, you try to pass in a variable through octo.exe to deploy, and Octopus Deploy completely ignores it. Well, this prompt for value, if you don't check that box, then this variable is not marked as incoming, okay? So you need to actually check the box, and then it'll actually accept the value that's on octo.exe command line. All right, another aspect that really has architectural implications is where to put the approval. I've already talked about it, and of course we're kind of disabled here, but just to show you can put the human approval, the manual intervention step in Octopus Deploy, but if you're using Azure Pipelines as an orchestrator, you want to put the approval there Otherwise, Octopus Deploy is going to be sitting blocking and waiting, and then Azure Pipelines is going to be sitting and waiting. And so that's where you want it. Now, if you have a web application and a SQL Server database and a simple application like that, then literally your Octopus Deploy project, it's going to look like this. It should be this simple. Now, baked into each one of these tasks is so much intelligence about poking in JSON variable names and XML variable names and pulling those from the variables, and also with deploy.ps1 and post-deploy PS1 PowerShell scripts. You can have any arbitrary logic. So when we see something nice, clean, and tight like this, we know that Octopus Deploy is implemented properly. When we see just scrolling, PowerShell task, well, essentially we've created what we're seeing is a procedural program implemented with Octopus Deploy, and that's not what you want to see. Okay. Now, variables have architectural implications. Huge architectural implications. You see with database name, this little icon here, that means that it's marked for incoming. It's going to come in from the outside on the command line. But a variable is a piece of data, okay? So architecture hat on, think about it. Who owns it? Is the system of record the build system or the deploy system or some external system where data needs to be pulled in? Follow the dry principle. Don't repeat yourself. If you don't create a strategy for configuration management, then you're rolling the dice on a management nightmare in short order. Every system has configuration management needs. You must design it. Remember, design doesn't just happen. It has to be intentional, okay? This is not something you just want to leave to the individual developers in order to define variables and just make the lists, especially if you have multiple production environments, one for each customer, and you're using the tenants feature. You will have variable explosion and you will not be able to manage it. So this is something, raise up the variable structure to the architecture level. Don't just say, oh, the developers will handle it. And some of you might already be in that kind of nightmare, but it's a really, think strategically about variable management. Now, let's talk about full system tests and the Octopus life process as we're going through here. So here's a scenario that's a complete pull request, okay? So the test scenarios are specified. A developer changes code. Then there's a private build they run in their local box. They commit to source control. Then a continuous integration build runs. We package it up. Then it's going to be deployed via Octopus Deploy to the first line full system test environment. We call that TDD. And then the control is going to be returned to Azure Pipelines, which is going to run the automated acceptance tests, tools like Selenium or whatnot, tests that can only run in a fully deployed environment. Then all the tests pass. So now the developer comes back and says, great, it worked on my feature branch. Now I'm going to create a pull request. Then someone on the team does their inspection, does the checklist, the pull request checklist, and accepts that into master. And now it'll actually go back to the continuous integration build, do the deployment again, run the tests again, and then it'll be deployable to the UAT environment and the production environment. Okay, that's the routine. So this part of our Kanban board, test design, development, and functional validation, that's where the full system test and that first automated environment type come into play. Now, as we're running our full system tests, you want to make sure that you're capturing screen grabs. And so this is the inside of a browser window where we're typing in text boxes and hitting buttons, and you can see that we're about to click that button, and this is what the screen looks like for our automated test. You want to make sure that you're enabling attachments as those tests are running so that you can see what the screens look like. Now, you want different steps running in each environment as Octopus goes from environment to environment. And so you see things like recreating the database schema and running acceptance tests. We're going to do that in the TDD environment, but we're not going to do that in UAT and prod. We want to make sure that we are not doing anything in production for the first time, and that everything we're doing in production has been done in at least one previous environment, okay? Now, let's get on to telemetry observation. This is our last of the 7 key steps in DevOps architecture with Octopus Deploy. And we have our runtime. Application Insights is a great application performance monitor. New Relic, Stackify, all those fit into that category. But we need to be able to observe. So what the heck is telemetry? Let's go through that. There's 3 types. Logs, you all know what a log is. And it's just free-form, flat text message of something that happened. Okay, it's completely up to you to put structure in it. Then there's metrics and events. Think about organizing a data warehouse or a star schema. In your own applications probably have a star schema that has fact tables that have dimensions and facts. Dimensions are events and facts are metrics. Metrics are numbers. They can be aggregated, sum, min, max, average. They are numbers. Metrics are always numbers. Events are always enumerated strings. An example of an event would be successful login. And then you can do a count of successful logins and even common transactions. You can put how long the transaction took from the time the user clicked a button to when it actually finished, and that is a metric. So that you can look for a certain transaction type, which is an event, and then you can average the processing time for an event and then come up with a pretty nice graph over time, because you can group by time and day and hour and minute, all that. So metrics and events are the other 2 legs of the 3-legged stool of telemetry. It enables you to create a data warehouse from the running of your application. Now, Application Insights gives you a wealth of telemetry information kind of for free, so I'd highly encourage you to turn it on. And also, one thing that you might have seen in the Octopus Deploy configuration is a release marker. When we do a deployment to any environment, we want Octopus Deploy to integrate with Application Insights and say, hey, I just did a deployment, okay? And then we can know exactly when the deployment happened. And if the numbers start to go sideways, then we can know that the deployment just happened and it was a cause. If we were to click on that marker, then we can see exactly what build and what build number and all kinds of information about that release. All right, so that is the 7 key elements of a DevOps environment, those are the points of success with Octopus Deploy. There are countless clients that we've helped with this, either to inspect the Octopus Deploy implementation that they've already done or set it up for the first time, giving them the pattern. You can go on our website, and I'd encourage you to do that in order to kind of see some of those things and some of the quotes. But when you do it right, soup to nuts, Octopus Deploy, the implementation just falls into place. And so there's a few ways we can help you, either with an Octopus Deploy Jumpstart, or we have a 30-point inspection that we can do on your existing Octopus Deploy setup. But our goal is to make your team self-sufficient and to point you in the right direction, to help you get the right strategy, to help you get the right implementation. And every client that we've engaged with has smart, motivated, passionate people. And when we just help them get going in the right direction, they're able to take it from there. And so we know that'd be the same with your situation as well. So one way to get some help is just to get some simple advisement or whatnot, however small, even just a question or over the phone. I'd be happy to take a phone call. It's on the screen. You can also download one of our case studies. Rain has put the link in the chat to download a case study that's available to you. And so I'm going to leave this contact information up on the screen. I love to answer questions. And if we need to set up a video call, happy to do that as well. And whether or not you're using Octopus Deploy for the first time or you already have it implemented and just looking to solve a few key problems. I hope this information was helpful to you. And if we can help make your Octopus Deploy journey a more pleasant one, then please give us a call. Have a great day.